So let's see how we can use some of these new formulas. Right, first, I've summarized them here, right? These are our double angle formulas and our half angle formulas. And we're going to do the same kind of things we did here with the sum and difference formula, right? We're going to find the exact values of angles that we didn't already know just from looking at special triangles and a unit circle. So how about this thing? Well, we're going to do the same kind of thing that we did before, right? I'm thinking, is there an angle I know the sine and cosine of where when I divide it by 2, I get 75? Right, so I'm thinking 150 is going to work. This is the same as the sine of 150 divided by 2. So 150, that's going to be the alpha or theta, whatever the variable is, in our formula. So now my formula says, right, the sine of half an angle, this is the square root of 1 minus the cosine of the angle, that's 150, divided by 2. And I'm going to kind of put this in parentheses off to the side, plus or minus. We're going to have to stop and think about the sign of this thing when we're done. All right, so what is this then? Let's see, this is the square root of 1 minus the cosine of 150. That's minus the square root of 3 over 2, all over 2. And now we've just got some simplifying to do. Right, this is the square root of 1 plus the square root of 3 over 2, all over 2, which is, let's see, let's do a common denominator. This is the square root of 2 plus the square root of 3 over 2, all over 2. And that is, let's see, the square root of 2 plus the square root of 3 over 4. And that square root of 4 in the denominator, I can simplify. This is the square root of 2 plus the square root of 3 all over 2. And should I make it positive or negative, that square root? Well, I know where I want this to end up. 75 degrees is a first quadrant angle. Well, yes, first quadrant angle, which means the sign is going to be positive, which means I want to take the positive square root here. So that will be my final answer. All right. How about this one? All right, go ahead and try this one. See what you come up with. Okay, 15 is half of 30. Right, so I'm going to make this the sine of negative 30 degrees divided by 2. And negative 30 is what I will put into the formula. All right, so let's see. This will be the square root of 1. You remember the sine formula has minus, so this is going to be 1 minus the sine of negative 30 degrees over 2. So let's see, square root of 1 minus. What's the sine of negative 30 degrees? That's going to be negative square root of 3 over 2. Negative square root of 3 over 2 over 2. And now I've just got some algebra to do. This is the square root of 1 plus the square root of 3 over 2 over 2. And I'll do a common denominator. Square root of 2 plus the square root of 3 over 2, all over 2. So that's the square root of 2 plus the square root of 3 over 4, which is the square root of 2 plus the square root of 3 over 2. And I see here I have to make a decision. Again, thinking about the signs. Negative 15 degrees is a fourth quadrant angle. Because it is a fourth quadrant angle, its sign is going to be negative. So I'm going to put a minus sign out in front here. Right? There's my final answer. Now, another way you could have done this, right? Another way you could have done this, you could have started off using our sine negative angle identity. You could have made this minus sine of 15 degrees. And then in the end, you see, you would have picked up the minus sign from out in front. I would have left the square root positive and gotten the minus sign from here. Either way, you end up with a negative number, which is what we needed for the answer. Okay, so what's next? First, before I talk about what's next, you might have noticed that I didn't do something, right? I didn't do our usual routine here with the double angle formulas. And there's a reason for that. The reason for that is that you can't. Okay, not with the angles that we know. All right, so to come up with the last questions, with the half angle questions, what I did is I took an angle that you know, I divided it by 2 and said, okay, there you go. What's the sine or cosine of that angle? You can't do that with doubling, because if I take any angle that you know and double it, I'm going to get an angle that you know. If I take 30 degrees and double it, that's 60. Well, you know what the sine of 60 is. If I take 45 degrees and double it, that's 90. Well, you know what the sine of 90 is. There would be no point in using the formula. You could just give me the answer, right? That's why I didn't do this with the double angle identities. So what are we doing next? We do have some more formulas. I'm sorry to say. Like I said, right? Trigonometry is just full of these. Next, we're going to look at two things that are called the law of sines and the law of cosines, and those are both very practical formulas. In the lecture after that, we're going to look at some practical problems that can be solved, in particular using those two identities.